And now we come to the most powerful way to solve problems like this, the numerical approach. What is the numerical approach? Well, the idea is take our problem, in this case the falling base jumper. This problem is tricky because the velocity and forces are constantly changing. But they don't change that quickly. We know it takes about 2 seconds to fall. But over, say, 0.1 second, the force isn't going to change very much. So here's the idea behind the numerical approach. What we will do is we will divide the falling motion into a whole series of little falls, each maybe 0.1 second long. And for each of these little falls, the acceleration won't change very much. So we can calculate them using the normal projectile motion equation, just s equals ut plus half at squared, which is very easy. And then all we have to do is add them up. So we've replaced one long tricky problem with a whole bunch of small easy problems. Small easy problems are what computers are good at. So what we can do is if we can tell the computer how to calculate each one of these small steps and then just daisy chain them together, count one after the other, we can calculate the total motion. And if you make the steps small enough, we'll get a very, very good answer. So the benefit of the numerical method is it's mathematically very simple, and you can solve incredibly complicated situations. You can solve situations like this with forces changing in the strangest, most bizarre ways, things you could never solve by any other method. The drawback is you do need a computer, because you're going to have to do these little calculations over and over and over again, and it gets pretty boring doing them by hand. And to get it accurate enough, you'll have to make the time steps really very small.